Hi, this is Julian Hunt. I work at EASA and I'm going to present my research on using the jet stream for sustainable airship and balloon transportation of cargo and hydrogen to the AEROMEET 2022 conference. I can't be present today because I have a very important meeting at EASA for talk about my work plan in 2020. Unfortunately, this meeting was scheduled exactly at the same time as this presentation. So you can please contact me if you're interested in the research on my email, which I'm gonna share with you in the end of the meeting. Thank you so much. So firstly, I'm gonna introduce you EASA. EASA is the International Institute for Applied Systems Analysis. It's based in Luxembourg in Austria, close to Vienna. It was founded in 1972 by the US and the Soviet Union with the intention of collaborate research during the Cold War and make scenarios for the future if there was a nuclear bomb, Third World War, things like this, nuclear war. After the collapse of the Soviet Union, we have several countries that still invest in maintain the EASA, and EASA has a lot of programs which have projects with funding from different sources. In the summary of this presentation, I'll talk about airships, the hydrogen economy, and the use of the jet stream for cargo transportation and hydrogen. Airships, they thrived since the 1920s, 1930s, but they ended with the collapse of the Hindenburg. So the Hindenburg disaster in 1937 drew an end of this era and started the airplane era. Comparing the main aspect of airships in 1930s, you have that the technology wasn't so advanced. For example, the bags that hold the hydrogen were made of cow intestines. There was no reliable weather forecasts, and the controls had to be done manually. Today, we have much lighter materials, more resistant, cheaper materials that can be applied in airships. We have very reliable weather forecasts, and the control can be done automated with much reliability. So we're in a much better position to develop this airship industry today. One drawback, however, is that helium, which is the gas used for the lighter than air gas used today, comes from as a byproduct of the extraction of natural gas and oil products. And if we want to create a future airship industry, it will have to be with hydrogen because helium relies on a wealthy natural gas and oil industry to become a viable solution. As we want to stay away from fossil fuels, helium is not an option, so it has to be hydrogen. So you have this risk of explosion, but that's the only thing we got. If we want to go sustainably. The other point that makes the hydrogen economy so important today is the shift to sustainable energies, and the one that is the most apparent in the last few years is the rise of the electric cars, mainly with Tesla. So Tesla now has a market capital of Toyota, Volkswagen, BYD, Daimler, Ford, General Motors, BMW put together. And some of these companies, for example, General Motors is going all electric by 2030 also. So and other companies also going electric. So this is a huge shift for the automotive industry, which consumes most of the oil in the world. So the oil and gas industry realized this, the threat for their existence, and they are considering the possibility of creating a new industry based on hydrogen. Hydrogen cars will probably not become a solution because batteries have much more advantages. But for example, shipping, aviation industry, energy storage, hydrogen can play several other roles and can use the existing infrastructure from the oil and gas industry, which if it's not used with hydrogen, it will have to be dismantled in a future sustainable world. So the plan from these oil and gas industries is to invest in blue hydrogen, which consists of extracting natural gas, processing it, transforming it into hydrogen, capturing the CO2 and storing the CO2 where the natural gas came from. So this technology, blue hydrogen, will have a reasonable cost, which will allow the hydrogen economy to become viable alternative. And then after the hydrogen economy is a viable alternative, other sources of hydrogen will then become competitive with the blue hydrogen. For example, green hydrogen from renewable sources, yellow hydrogen from biomass, and CCS, for example. But however, one big challenge for the hydrogen economy is the transportation. So the pipelines have to be operated at extremely high pressures to transport a significant amount of hydrogen, because hydrogen has a very low volumetric energy density. So pipelines are very expensive, 3 times more expensive, 3 or 5 times more expensive than natural gas. You can liquefy, but you need to reach very low temperatures, minus 250 degrees Celsius, and you lose a lot of energy with this process. You can compress hydrogen, but the hydrogen has a very low volumetric density, which is very complicated to compress. You can transform into other molecules, for example, ammonia, toluene, or several other energy carriers molecules that you can use to transport hydrogen. But this research, we proposed air. So the proposal in this paper, this research, is to transport hydrogen as a gas, as a lighter than air gas, in balloons or in airships. In this case, in this slide, we're proposing the use for airships. So the idea is to carry hydrogen with cargo. So then you deliver cargo and hydrogen. The cargo can be liquefied hydrogen itself, for example. Hydrogen has a very low mass density, so it could be an option to transport hydrogen with airships. And then after the cargo and the hydrogen is delivered, so you can deliver the hydrogen for lifting the airship itself, because on the return trip you will require much less hydrogen because you delivered all your cargo. So then you can deliver cargo, for example, of mobile phones, cars, and in the trip back you will come back with less of the lifting gas, because you don't need so much lifting gas because you delivered the cargo. So you can combine cargo and hydrogen delivery with airships. And the other proposal with balloons, there was a project developed by Google, which is called the Loom project. And the proposal was to have thousands of balloons with satellite equipment that would allow you to connect to the internet with balloons. So the balloon will send signals, and then you receive signals and send back to the balloon, and in this way you get connected to the internet. The project similar to the Starlink project from Elon Musk, but that was from Google. It didn't work out because after a couple of months the balloons will concentrate in the South Pole and the North Pole, and then it turns out that it wasn't a great idea. But this could be a case for transporting hydrogen because it doesn't need to be sitting there forever. It will go from one location to another location. Maybe you can have some balloons sitting in the stratosphere waiting to be delivered somewhere, and then the balloon can go change altitudes so that they will catch the prevailing winds that will take it to its final destination. So the idea of this paper, this research, is to use the jet stream in order to transport the balloons and the airships. And what's the jet stream? The jet stream is basically the connection of the Arctic pole and the Antarctic pole with the Ferrol cell in the global atmospheric circulation. And for example, the cold air is denser, so it goes below the Ferrol cell. The Ferrol cell, you have wind velocities of 30 meters per second, kilometers per second, but once it goes up, because it hits the polar cell, it lowers the pressure. When you lower the pressure, you increase the velocity. So the speeds can reach up to 300 kilometers per hour. There are locations with average speeds of 160 kilometers per hour. So very high velocities you get in the jet stream, and airships can surf the jet stream, balloons can surf the jet stream. It's proposed in this paper. So this is the paper we published in Energy Conversion Management. There is a competition for going around the world on balloons, and the latest balloon round around the world record was made from Russia, for a Russian guy in the southern hemisphere, and he traveled from Australia. So he left Australia, he went across the Pacific Ocean, and then he went back to a location 100 kilometers apart. So he had some propane gas in the balloon, and he could warm up the balloon or leave it to cool down, so then he could control the altitude. Controlling the altitude, he will get winds at different directions, and of course he had to foresee the winds in the future in order to reach his initial destination. He didn't really hit the exact destination, but he got really close. The funny thing is that with balloons you can only go up and down. Of course, with airships you can better control because you have propellers also. So this research, we got data from the AEROMEET, which is a project developed by the ECMWF, which is a European company that produces weather forecasts. Very good weather forecast. It's the best company in the world that does this. You have also the GCF, which is GFS, which is from NASA, but this usually is better. The ECMWF, AEROMEET. AEROMEET is the historical data. So we get all the data for 2019 at different altitudes, pressure levels, and then we create an average for the pressure levels, and we assume that the average is we assume that the airship will travel on the average speeds, and we also take into account the moves up and down. So we want to avoid going through locations where you would change latitude a lot. So then we proposed, and we also proposed to cross major cities, and these were the optimum routes for using the jet stream, taking into account the highest west to east speeds. So the jet stream doesn't fly east to west, never. It's just always at west to east. So west to east, and we also reduced the possibility of going down. So there are some locations on the Earth where the wind changes the latitude a lot, and we wanted to avoid that. So this was the optimum locations. For example, we'll go from Las Vegas across the US. We'll pass through Spain, and then Israel, uh, Pakistan, India, China, Japan, and then go across the Pacific. In the southern hemisphere, we'll cross Santiago, Porto Alegre in Brazil, uh, Cape Town in South Africa, Perth, Sydney, and we'll pass close to New Zealand. So these are the name of the cities here. In the winter of the northern hemisphere, the jet stream is stronger in the northern hemisphere. In the winter of the southern hemisphere, the jet stream is stronger in the southern hemisphere. So in the winter, the jet stream is stronger. The jet stream itself varies significantly with the height, and the maximum speeds reach up to 433 kilometers per hour at a pressure level of 250 hectopascal. The average speeds are the highest at 200 hectopascal, which is 165 kilometers per hour, so very high speeds. So using the methodology that we have, which is vertical minus horizontal speeds minus vertical speed, we get to these results, which this is the equator, this is the North Pole, this is the South Pole, this is the North Pole, and the best location is minus 30 latitude in the southern hemisphere. In the northern hemisphere, the best is somewhere around 35 degrees latitude. So these are the main results of the paper. And we have that how many days it takes to fly from one city to another. It turns out that to go around the world, on the northern hemisphere it takes 16 days, and on the southern hemisphere it takes 14 days. And here we have the number of days for going from city to city. Apart from transporting cargo, and it can transport hydrogen, and one airship flying across the world in a periodicity in the time that we calculated would be enough to transport one airship would be enough to transport the electricity in this Tanger solar power plant in China with 105 gigawatts capacity, and the size of 43 kilometers squared. So yeah, you can transport a lot of hydrogen in an airship. Yeah, so the airship that I'm proposing here has dimensions 10 times bigger than the Hindenburg. Yeah, so you have the Hindenburg. So we're talking about an airship here with a length of 2.5 kilometers, and 400 meters. So extremely large airship. This would be not practical to maneuver, and if you have a strong wind and you want to dock, that would not be possible. So instead you can use balloons. Balloons have the advantage that on the surface they are 10 times the size, the volume that they are in the stratosphere. So using balloons is much more practical. It might be even lower cost. So you have to have something to compress the hydrogen to control the altitude, of course. But once the balloon is on the ground, it's much easier to control because the size will be 10 times smaller than it is in the stratosphere. So this paper received much attention from the media. EASA made a press release. There was an article from NBC News telling about this research, which was very nice. And the conclusions from this research is that Airship has a prominent future with the new technologies and weather prediction. Helium should be replaced by hydrogen for future sustainable of transportation, the future sustainability of transportation. The hydrogen economy might replace the current oil and gas industry in the future. So it will be important to find ways to transport hydrogen. The jet stream can be harnessed to transport cargo in hydrogen at very high speeds with very little fuel costs. And a trip around the world would take 16 days in the northern hemisphere and 14 days in the southern hemisphere. Sorry. That's it. Thank you so much. This is my email. My name is Julian Hunt. My email is hunt@easa.ac.at. Thank you so much for your time. Looking forward for your questions. Bye bye.